have done the bromination of aniline. Okay, so we have found that we have got when you do the bromination of aniline, then you get 2,4,6-tribromoaniline. That is, both the ortho position and the para position get substituted. So now we have to go for, suppose you want to introduce only one bromine. That is, we can go for control bromination. So let us do the control bromination. Controlled bromination. Now, control bromination under the same heading. See, I'm very sorry. I want to tell you something. Well, while I have done the reactions of aniline, so first we have done the reaction with salts, then I have done reaction with then I have done alkylation, then I have done acylation. In the acylation reaction, I have done the reactions of aniline with acid chloride. Okay, so I have taken aniline and acetyl chloride to get N-phenylacetamide or acetanilide. But a very important reaction which I did not do. I'm very, very sorry for that. Because generally, acylation of amines we do not do with acetyl chloride, because acetyl chloride, first of all, it undergoes hydrolysis very fast, and it is very difficult to use this one because it irritates our eye. If you keep a bottle of acetyl chloride open, just you open, you simply cannot stay in that room. Okay, it's an extremely lacrimatory substance. So we do not do the acetylation with acetyl chloride, but we do it acetic anhydride, and that is the most important reaction which I forgot to do. Maybe it's because of old age, or maybe I'm teaching without opening the book. So in this one, I will do it. So please excuse me. Control bromination of aniline or aromatic. See here. So when we do the, okay, I'll put on laddu inside. When we take aniline, and if you do the bromination, then bromine comes here, here, and here, so we get 2,4,6-tribromoaniline. We do not want so many substituted product. So what we'll do, we'll try to stop the entry of bromine from both the ortho side. So that is, we'll put something to guard this position. So what we'll do, we'll take here acetic anhydride, acetic anhydride, and we'll hit this one. See here, and this it will undergo acylation. Acetic anhydride is stable, does not undergo hydrolysis very fast in the extraordinary condition, and moreover, it doesn't irritate your eye. So you'll get this, and you get here acetic acid. Okay, this is called N-phenyl acetamide. See, we know what is acetamide. This is acetamide. Okay, so one of the hydrogen is being substituted by phenyl, so we call it N-phenyl acetamide. Or it has a common name also. We call it acetanilide. It is more popularly known as acetanilide. Clear? Then to that we will add bromine, and we'll take acetic acid is solvent because that is not soluble in water. So bromine in acetic acid. Okay. Then we'll heat it. Then you'll find bromine will come here because these two, see, this carbon nitrogen single bonds always undergo rotation. So it will undergo very fast rotation. So in this way, both this entry of the bromine at both the ortho position will be restricted. So because para position is free, the bromine will come here. All right. So you get here now. NH CO C3 plus H. Okay. This is known as para bromo acetyl. Para bromo. My handwriting is also so horrible. I think it is not possible to change in my life. I think I have to take another bar. Para bromo acetani LITE. Okay. Para bromo. And what will be the IPC name? It is, and see, it is a phenyl is substituted here, and this is substituted phenyl. I have already taught you how to name it. And 4-bromo phenyl ethanamide. All right. So we have got it. After that, we will do hydrolysis. So we'll boil it with dilute acid. So what you get? This portion will break. This will break. So you'll get here now 4-bromo aniline plus acetic acid. So please write. I have to put ink also in my pen. Important for conversion, both in CBSE and MBOS. They will give you convert aniline to 4-bromo aniline. Yes,
sir.
Good girl. And what about these other lazy people?
Finished, sir.
Okay. Now see here.
Done, sir.
Yes. ठीक है करो
জল দিয়ে করতে হবে জল গরম হয়ে গেছে এই ভাঙা বালতি থাকে না এই চাদরটা ভিজিয়ে রেখে দেবে ভাঙা বালতিটা পরিষ্কার হয়ে যাবে আর
Right,
Okay.
sir.
Now suppose question comes. Suppose the question comes, convert para toluidine to 2,6 dibromo 4-methyl aniline. Then please don't faint. Question is convert para-toluidine to 2,6-dibromo aniline. Okay. So what we'll do now? See here. This is called 4-methyl aniline is called para-toluidine. Some of the names you have to remember, you can't give any excuse. Sir, it's difficult to know. When you can remember the name of so many of your friends, difficult name, this also you can remember. Para-toluidine. Okay? So exactly the way that we have done, you do it. First you do the acylation. After acylation, okay, then you do the bromination in acetic acid. When you do the bromination, see here, the para position is blocked. Now in that, when it is, you have blocked it, so in that case you will find the bromine will go both to this position and this position. All right? Then after that you do the hydrolysis and get them. I give you 2 minutes time to do it. Be little smart. Sitting in hydrogen, you can write in this way, shortcut. You need not even write this one. You block, na? It will come here. Finish.
So with N-phenyl acetamide, we get HBr, sir. Or
Which
it
one,
should the first.
Oh, correct. I have made a mistake. Good boy. ये गंजी का बिजाना है नहीं तो जो गंद गंद जाए दुल रही थी ये नहीं गया होगी
Excuse me, sir.
yes
Where is the methyl in that second compound?
Michelle, I forgot to write.
Yes, sir.
Hey, now onwards, if you are slow, I'll simply rub the board. If you cannot, it is your problem. The thing which I'm supposed to teach you in one class, you are taking two classes. Okay. Now, we'll go for nitration. Second reaction, nitration. Second, electrophilic reaction. দুটো আমি মজা রেখেছি আপনি দেখেছো তো না একটু দেরি আছে nitration of aniline with a mixture of concentrated HNO3 and concentrated H2SO4. Please remember, this is called nitrating mixture. It is called nitrating mixture. Okay, that's it. Gives this reaction is very interesting and very important. Mixture of ortho nitro aniline. Ortho nitro aniline is called what? Are you listening? It's called 2-nitro. So by theory, it's supposed to give ortho and para. Then para nitro aniline. What do you call it? 4-nitro aniline. And meta is not supposed to form, only nitration it forms. So because this is an exception and it's very important for exam. Meta nitro aniline. Okay, C-nitro. Okay. So I'll write now. This aniline okay. This is ortho nitro. Okay. Plus this is, as per our theory, is supposed to give a mixture of ortho and para. Why? Because amino group, electron donating group, always direct the electrophiles to ortho and para. But along with that, you also got an exceptional product which does not form with any other reaction. Is this. Okay, that is, you get here ortho nitro aniline, no, 2%. It is para nitro aniline 51%. That you know, because of steric hindrance, it is less. It is no steric hindrance. And this is meta nitro aniline 47%. See, it's very exception. I will explain. Right.
আগে তো জল করতে দেয়নি
না না ওটা তো আমার কাছেই আছে এটা তো সানানো গিয়েছে না
নেয়নি
না না
বলে না তো এগুলো চেক করো না শুনে কাজ করে বলে চেক করো
Sir, done.
আরে এখানে তো পড়াশোনা করতে আমার স্টুডেন্টদের হয়ে গেছে যখন ওদেরকে বড় তাড়াতাড়ি করতে তখন এগুলো তো করলে হয় ও আসবে 10:30 করে
তাহলে কোন জলটা দেখতো
ও মানে না ঠিক দেখতে হবে এই তোমার কাজ করে
see now these two are being formed by our the theory that we say that by resonance amine group increases the density of electron at ortho para. Okay, but why did it form? So let us try to understand. Okay, see, in nitration we are using strong acids. We are using nitric acid and we are using here sulfuric acid. Sulfuric acid is stronger than nitric acid. So in that case, aniline is a loose base. So in that case, what we will find, a part of the aniline reacts with sulfuric acid to form salt. Okay. First I'll show you, then I'll give you the explanation. See here. You will not write anything down. Okay. So I'm not writing sulfuric acid, I'll write here H plus. And here I'll write H2. So what is going to form? You will get here N8, 8, 8, and we know that amines will always form salt, will undergo protonation. So this is aniline and this is anilinium. You get now here anilinium. This, if I write the complete equation with sulfuric acid, one hydrogen from sulfuric acid will come here and you will get anilinium and anion will be HSO4, anilinium hydrogen sulfate. That at the first reaction we have written it. Look now. In this case, this lone pair has gone for resonance by which you find negative charges here and here. Does it have any negative charge? See here. So here nitrogen is tetravalent, but normal valency of nitrogen is 3. Moment nitrogen become tetravalent, or we call it quaternary, then nitrogen, this nitrogen immediately changes its character. Instead of giving electron, it wants electron. That is, it becomes a very strong electron withdrawing group. So as when electron is being pumped inside, electron increases at ortho and para, when it withdraws, it will also withdraw electron from ortho and para. So these two centers will be highly electron deficient. See, electrophiles are electron deficient, and so electron deficient species cannot go to another center which is electron deficient. So comparatively now, which is electron rich? This is electron rich. All right. So now in that case, the nitration will occur in this place. Okay. So right now here, HNO3 plus H2SO4 will give you this. All right. Then after that, what we'll do now? We'll treat it with base. We'll neutralize the reaction, and we'll get here NH2 NO. So please write this equation. After that, I'll write down the explanation for you. Please write. Finish writing.
Yes, sir.
Okay, right now. Okay, I'm going to write. Right. Nitration of aniline is done in presence of strong, in presence of concentrated acids. Okay. Okay, right. Aniline being a Lewis base reacts with acid to form any aniline ion. I will turn to this. Okay. The quaternary, Mr. Traveler, quaternary nitrogen atom of any linear ion is a strong electron wait we'll remove this. The quaternary nitrogen atom of linear ion is strong electron withdrawing in nature. Electron withdrawing in nature, and it deactivates both ortho and para position of phenyl. All of you have written this upper portion. These equations have you written?
Yes, sir.
Yes, sir.
Then let me grab it. Huh? Okay. So the nitration occurs at relatively electron rich meta position, forming meta nitro amine. Okay, this is the explanation. So again, I'm telling you this aniline lone pair, because of aniline lone pair, it is a Lewis base. So Lewis base will react with Lewis acid, so it will form a salt. So the nitrogen becomes tetravalent. Tetravalent nitrogen does not have any lone pair. In fact, it tries to withdraw electron. In this process, it withdraws the electron from the phenyl ring, and both ortho and para position become electron deficient. Initially, meta was electron deficient. When ortho and para has lost the electron, now meta position is, as it is not disturbed, in that meta position has become electron rich. It's not that meta has gone extra electron. No, extra electron has not gone to meta position. His neighbor has become poor, so he has become rich. So in that case, nitration will occur at meta position. This is 100% chance is there for emboss to come next year. 100% chance. Now we'll go for controlled nitration. Huh? Well, I'll not do, you'll do it. Same method. We'll take aniline, then we'll react it with acetic anhydride more. Then you will get N-phenyl acetamide or acetanilide. Then in case of bromination, we have done bromination. Here you will do nitration. So it will nitropropyl will go to para position. Then after that, we'll do the hydrolysis. Do. Controlled nitration. So this is then acetic anhydride. Instead of writing such a long formula, you can write like this. Then we write here heat. Then what you will get here now? You will get here now acetanilide. Please get little acquainted with the common name, okay? Because you write here now acetanilide. I will not write. Then we'll do nitration. This is the nitrating mixture. Okay, we'll write here now concentrated, and here we'll write heat. Heat. Oh, sorry. We're going to write here now NH. NHCO-CH3. This is also you can write. Huh? And here you will write nitro. I'm not going to write. Okay. Then after that, okay, I'm writing. Dangerous people. Then you get here. Both of them are important. Control bromination and control nitration. এরকম করে অন্য কাজের মতন করলে তো হবে না, আমি তো পড়াতে হবে। রান্নাঘরে সবকিছু ভর্তি করো, আর পুরো বড় বালতিটাকে ভর্তি করে উঠাবে না, ওই বাকি যে রান্নাঘরের মুখ দিয়ে পড়ে।
So done.
Good, good. So we have done bromination, we have done nitration, we have done. Then we'll do now sulfonation. পুরো ভরা বালতিটা বিনা। Aniline on treatment with concentrated H2SO4, just now we have seen, from anilinium hydrogen sulfate. Because anilin is a base, and sulfuric acid is going to react to form salt and salt. Anilin on treatment with concentrated H2SO4 anilinium hydrogen sulfate, which on heating for 4 amino benzene. Okay. 4 amino benzene. Why did I write like this? I did not. I rubbed it because from here to here is single name, single word. Then after that there will be a gap. 4 amino benzene sulfonic acid. Okay. Now its common name is sulfenilic. This is a common name. Sulfenilic acid is a very important ingredient for making different dyes, indicators, and also medicine. Okay, sulfenilic acid. Okay, so I'll do that now. Yeah. So this is N. I intentionally put the lone pair because to indicate it is a base. This is concentrated sulfuric acid. Okay. So you'll get now here. See, it will be NH3 and HSO4 minus. So you'll get here aniline. And this is called anilinium, like ammonium. Anilinium. So hydrogen sulfate. Okay. This you don't have to heat. It's room temperature. So now you heat it strongly. See, it will undergo decomposition. You lose the molecule of water. Okay, and you will get here NH2 and SO3H plus H2O. See, it's very interesting. It undergoes rearrangement. It undergoes rearrangement reaction. So you get this. Okay. So and here I cannot write because by bend no, that I have back pain. So here you will write 4 amino benzene sulfonic acid, and within bracket you will write this name. Do. Or third palat.
Yes, sir.
Finish.
Yes, sir.
Okay. See now, one important property. We know most of the organic compounds are not soluble in water. Most, only few of them are soluble in water. Why? Because the aromatic and aliphatic groups are hydrophobic in nature. But we find this is soluble in water. This compound. Organic compounds, their melting point is low. Why? Because they are covalent. But we find melting point of this sulfonylic acid is very high. Okay, so let us talk something about it. Everyone, sir, now what Miss is teaching you in school? Huh?
It's the second chapter, alcohols, phenols, and ethers, I guess.
Okay, so right now, first I let my eye vision. Write down. 4 amino benzene sulfonic acid or sulfonylic acid has unusually high has unusually high melting point and is soluble in water. So why it is like this? We'll write now here. This is because 4 amino benzene sulfonic acid exist as a dipolar species or Zwitter ionic form. So I'll first show you. See here. Very interesting thing. This molecule has both a basic group. See, this base. And this has, see, this is acidic. Sulfonic acid is much more acidic than carboxylic acid. So this is acid, this is base. तो क्या होगा? तुम पानी में डाल दिया तो acid will undergo dissociation. See here. Okay. In water it will happen. See. This lone pair will do what? When you pick up this one, and what you will get now? You will get here NH3 plus SO3 minus 6. In the same molecule, you have a positive charge and negative charge. So it's going to almost behave like a salt. The difference is that in salt, cation comes from one side and anions, cations and anions are two separate entities. But here, it is present in the same molecule. So this type of species are called Zwitterion. That is what is being taken from German. German, Zwei means two, not our Meghalaya Zwei, okay? Zwitterion. In the German, Zwei is ZWEI. Okay, German, I knew little bit of counting. Ein, Zwei, drei, vier, fünf, sechs, sieben, acht, neun, Zen. ZD and Zen is 10. Okay? So what will be the consequences I'm going to write? See, now you understood why it is soluble in water. It is soluble in water because of its ionic character. So write down now. This question did not come for many years. So we'll write now here. Solubility okay, we'll write 4-amino benzene sulfonic acid exists in Zwitter ionic form and so it is soluble in polar solvent like water, because we know like polar substance and salts are soluble in water. So because of that I written returning form, and so it is soluble in polar solvent like water. Melting point. Melting point. Now, why they have melting point? We know that salts are very high melting point because in salts the ions are being held by very strong electrostatic force of attraction. So to separate them, you require more energy. So they have high melting point. In 4-amino benzene sulfuric acid also, they exist in the ionic. They are dipolar species. So they also are closely packed within the crystal lattice and have high melting point. We'll write. Same thing I'm going to write. 4-amino benzene sulfonic acid. Let me write here, because in some book if they give you question paper, this common name then to khatam sulfonylic acid. Exist as Zuitak Judah and are very closely packed within crystal lattice by strong electrostatic forces of attraction. Hence, it has high melting point. Today, do you have class in school? Yes or no?
Yes, sir.
Yes, sir.
What time? What time?
Sir, 9
Sir,
o'clock.
9.
Yes, today I thought of finishing this one. Anyway, because diazonium will take around 1.5 hours. Forget. High melting point. Huh? So both of them are important. Why benzene sulfonic acid or sulfonic acid is water soluble, and why they have high melting point. Same thing you will find when you go to amino acids. Same amino acids also exist in the zwitterionic form. See, initially I was a little scared because we have started the tuition very late. So I don't think our condition is very bad. What do you think? Hello?
Yes, sir.
You are saying very half-heartedly. Okay. Now we'll go for Friedel-Crafts reaction. Friedel-Crafts. Friedel. See, we have found phenol also generally don't undergo Friedel-Crafts reaction. So aniline also will not undergo Friedel-Crafts reaction. Why? In Friedel-Crafts reaction, we take a catalyst AlCl3. AlCl3 is a Lewis acid, and aniline is a base, Lewis base. So before the reaction occurs, aniline is going to react with the catalyst. So it will not undergo any acylation or alkylation reaction. So right now, aniline does not undergo Friedel-Crafts Redox reaction means what? Alkylation and acylation. Why? This is because aniline being a Lewis base reacts with Lewis acid catalyst. Okay, we will write here. Okay, like anhydrous AlCl3 is because aniline being a Lewis base reacts with Lewis acid catalyst like anhydrous AlCl3 to form an adduct, means addition product. Hence, the reaction does not. Okay, so we'll write now here. So I'll write it in this way now. And I'll write here now. See, these are incomplete octet. So what is going to happen? So the nitrogen is going to supply. So you get this. So here I'll write here plus. The nitrogen valency has become 4 and aluminum valency is 3. Now it has exceeded one more. We're taking electron, extra electron, I will write. So here we will write adduct. I finish amines, but my question is that how to prepare, how to go for acylation of amine? We should know. If it is not possible directly, we prepare indirectly. So in chemistry, everything is possible. Suppose it is written, convert aniline to 4-amino acetophenone. Okay, see, कोई बात नहीं, एकदम हम लोग फटाफट बनाएंगे. I have taken aniline. Now this reaction you have already done there. Okay. So what you get now here?
আলু কাটবে গোল গোল করে আর বিনস আছে না লম্বা লম্বা করে বিনস আমি একটা ভালো করে দেখিয়ে কাটবে তারপরে পোস্ত করতে রান্না আমি করব
Oh, no, it's not possible. Sorry, I confused with phenol. Okay, I'll see. I confused with phenol because that reaction is called Fry's rearrangement. Okay, I'll see and do it for you. Thank you. Then,
Thank you, sir.
next Tuesday, I'm going to finish this chapter. After that, we'll